And welcome to Solidworks Skills video.
In this lab exercise, you'll be creating an in-context part using Solidworks. You'll be creating the part that's shown in red, calling it the carriage. One of the interesting takeaways from this exercise is that most of the dimensions, not all of them, but most of them, are the relation between parts. So you'll be converting entities, holes, locations, sizes, and so on between parts. And I think all told, maybe there are a half a dozen dimensions that you'll be typing in as numbers as we go along. There are two documents that you'll want to refer to. One is the drawing that shows three of the relevant dimensions. One shows an end view. This depicts how far it is from the nozzle to the underside of the V-rail and from the inside edge of the hot end to the front of the V-rail. Those are two of the dimensions. And a couple of other dimensions are the distance from the edge of the mounting plate for the Titan extruder to the center point of these two rollers and the other pair of rollers on the bottom. So that's one document. The other document you'll want to refer to is where it depicts some of the specifics of the carriage. Now notice that most of the dimensions are not here, but you do need a few of them, particularly when you're defining recesses for nuts. They're shown here, how deep they are, what the flat-to-flat dimension is. And for the holes themselves, you're going to want to have some clearance around your hardware and define the distance to the edge of the part that you'll be creating, because those are really not related specifically to any feature in the assembly. So let's go back to the assembly, take a look at it. Just for introduction, you can see that the rollers are quite well engaged in the V. I'll go to an end view of the thing so you can see it, and here you can see quite clearly that the rollers are tangent to and aligned with the V-rail or the V-slot rail. In addition, the way this assembly is put together, the carriage is mobile, so you can move it back and forth, and it gives you a sense of, once you start developing your 3D printer, how things might interfere, where you can attach belts, and the other fan, of course, and so you'll find this to be quite a powerful way to move your design much further down the road. Anyway, let's get started. I'm going to start with a brand new assembly, bring in many of these parts that are already pre-modeled for you. So your task, as I mentioned, is to create the carriage based on those other parts and the few dimensions that have been provided. Okay, as we get started, notice first of all that I have all of the relevant parts open. They're minimized down below. So for instance, if I want to look at one of the parts, here's one of the wheels with spacers. I have everything open along the bottom, and the reason for that is it makes it a little bit easier later on when I'm inserting elements into my assembly to have them already present. I don't have to go hunting for them. So I'll do a File, New, Assembly, and OK. The first part you put into an assembly is fixed in location. I think I'd like the V-slot rail to be that part. I'll place one of them there. So now we're ready to start adding things to it. The first thing I'll add is the extruder. I call it the Titan assembly. Here it is. It comes in just a random orientation, something we need to fix. Now, notice this part is movable, the other one is not. It's fixed in location. Let's start to relate the two together, and your guide for that is the documents that I provided. For example, let's look at the in-context example sheet, and this shows a few of the key dimensions, some of the few dimensions that you'll need to use. 0.6 inches from the bottom of the V-rail to the tip of the extruder nozzle, and 1 inch from the inside edge or surface of the hot end to the front of the rail. So let's do that first. Go back to my new assembly. I've got to find it here because I got quite a few things open. Alright, here we are. And let's do the nozzle first. You can do it in any order that you like. So I'll go up to Mate, click on the tip there. Let's define this as the bottom, so we'll align the two of them. They're backwards, so let's flip it around. And what we want to have it be is 0.6 inches down. So right now there it's 3 and change down where it started out initially. I'll make it 0.6 inches. Sometimes when you are changing your flipping or adding the offset, it tries to readjust, so you'll have to be aware of that. Okay, I'll accept that change because that's one of the first things. And I'll move it manually such that it's roughly in the location I want it to be. Oop, let me hit my F. Things got a little spaced out there. Hit F again. Alright, so I'm back. And if you recall from the drawing, we'll go back to that just a moment here. You see that the orientation is such that the fan, that little fan, is pointing away from the V-rail. So using that as an example, we'll go back to what we're working on. This fan is going to want to point out toward the left. I'm going to make this surface right here, which is the inside edge of the extruder or hot end, be coincident with the front of the V-rail, and now I'll move it out by 1 inch, punch in 1. So now I've actually achieved a fair bit right there. Now the extruder, the entire Titan assembly, is oriented such, and you'll see you can even move it. I mean, it acts as if it's a carriage already. Those two simple mates have already done a great deal of the work for us. So now we're ready to start adding the wheels and the other bits of hardware that will follow the constraints that I've just created. Before we proceed any further, it's important for you to know that you have to save the assembly before you create any in-context features or relations. Otherwise, later on, when you do try to save the assembly, you will end up breaking those features. So let's go ahead and do a file save right now. I'll save it under a name, and we'll give it a name, say for example in context 2.sldasm. So once having saved it, now it's safe to create in-context features, knowing that the assembly through which they relate to each other is stable and has a name that they can refer to. Now that we've saved our assembly, let's start adding some of the parts that will become important as we move along. The first parts we'll add are the rollers or the wheels. We do an insert component. Let's find them down on the list here. There are 2 with the spacers and 2 with eccentrics. I will use the push pin to allow me to add more than 1 of each. So I'll click on the push pin, then we'll do 2 of the wheel and spacer, 1, 2, right click to finish. Same thing for the wheel with eccentrics. Click on it, push pin, 1, 2, right click to finish. Let's now turn on the visibility of planes so that we can see how things can get aligned to each other. The first task is to align the wheels to the rail. So we'll go to visibility, turn on plane visibility. Now you can see the various reference planes that I've created that will help us to align the wheels to the rail. Let's do the spacer wheels first. Get the orientation of the view just right. Okay, we'll go to Mate. Notice nothing is selected yet. Click on the plane of one of the wheels, the plane of the V-rail. That orients it. We'll accept that. Do the same thing with the second wheel. Okay, they're good. Now they're on the wrong side of the rail. Let's move them over. I don't want to do that. Let's zoom in a little bit and select the wheel, move it through, move the other one through. Now they're in the right plane, but they're not touching the rail. Let's fix that. I'll find the V, the male V part of the roller, and made it tangentially with the rail, like that. Do the same thing with the second roller. Let's get the right surface here. There we go. Accept it. Now we'll repeat those operations with the eccentric wheels. The plane of the wheel, the plane of the rail. Accept it. Second wheel, rail. Accept that. And again, to a tangential mate of the V with the V. Bring it in. Let's get this guy, zoom in a little bit. This surface, let's clean this up. I think I forgot to accept that one. Let's finish that. And we'll do this one to the V-rail. Don't forget to accept it as I did a moment ago. Alright, so now all the rollers are properly mated with the V-rail. We'll have to do a little bit of extra work with the eccentrics in just a moment, but you'll notice that I can now move the rollers, all four of them, and they work. They'll rotate a little bit, but they stay properly tangential with. In fact, if I look at the end view of the rail itself, let me see where I can select that. There we go. We'll look at the end view and zoom in a little bit. You can see how nicely the rollers are now nestled into the V-grooves of the rail. This is good. Now we're ready to start defining the carriage itself. Let's turn off the plane visibility and once again save our assembly. We're going to rebuild and save, and now we know that there's no chance that we can lose the work that we've just done. Now that the wheels are oriented to the V-grooves, let's align them according to our document to the carriage, to the bracket for the Titan extruder. Going back to our drawing, let's take a look here and see what the dimensioning is. This shows in the upper left view here, let me make it a little bit bigger, that the center of the rollers is to be a ½ inch from the either side of the Titan bracket. So let's do that, in fact, in the assembly. We'll move things approximately to where they belong. That will help in a moment. Rotate the view around, do the same thing on the back. Get this oriented better. And I'm just kind of moving them lazily to a location that would help help the job. Zoom in a little bit. Now, as before, when we were looking at planes, we can also turn on visibility of the axes, and we can use those axes to as dimensions for from the edge of this bracket. So let's do that. We'll mate the axis with the surface, and we'll give it an offset of a ½ inch, 0.5, which is what was specified in the document. We'll accept that. Do the same thing for the other in the back. ½ inch. Now, for those more practiced in Solidworks, you can actually create a variable, a global variable, and have it relate automatically. That would allow you to change that dimension and have it affect all four wheels at the same time. We're not doing that in this example. So here again, that to here, an offset of 0.5, accept it, and here to here. Let's get the clear selection, got to get it right. Axis to the surface. I want to do it. Oh, I see, it's selecting the axis there. Alright, clear it out. This is I'm leaving this in the video because it's the kind of thing you'll fight with occasionally. When I was clicking here, it was trying to select that axis. Let's get away from that axis. Here to here. Make them coincident, and then offset by a ½ inch, 0.5. Okay. Now we're correctly oriented. Sometimes it's valuable to be able to understand why Solidworks isn't doing what you want. This was a good example. We'll accept that. And now when I'm finished with this, as I move now the entire assembly, notice that the wheels travel along with it. I mentioned earlier that I want the eccentrics to be oriented in a particular way. And let's study for a minute. I'll turn off the axis view. Let's study the eccentric and notice that the globe, if you will, the eccentricity is oriented away from that flat. So the extreme eccentric property is the furthest from this particular flat. And what I'd like to do is have the carriage that we're going to design in just a moment be such that the two eccentrics are halfway through their travel. So if I go one direction, turn it in one direction, I'm moving away from the rail, and then toward the rail in the other direction, and equally for both wheels. So let's do some alignment of these flats to the rail, and that will ensure that my carriage, once I create it, will have that property. So we'll go ahead, I'm going to click away from everything, clear out them, and then go into a fresh mate, and I'm going to mate that flat with the surface of the rail. Now initially it tries to do it parallel, which is not what I want. I want to have equal up and down adjustment, so I'll make it perpendicular. Well, that's just right. See, now if I were to turn the eccentric one way, it moves the wheel away, and the other way it moves it closer. Let's do the same thing for the other. Again, choosing the correct flat, I'll choose this guy here. And again, the face of the rail, let's get the right face here. Starts off parallel, we'll make it perpendicular. And now the wheels are not only spaced as one would want, as per the document, from the bracket of the extruder, they're oriented such that I get the best advantage of the behavior of the eccentric. So the next step is finally we're going to start creating the carriage. Alright, before we proceed any further, let's do another file save to preserve what we've done. Now let's fast forward and start to create the carriage, the reason we're here. Point one thing out, I want you to look briefly at the parts that the carriage will be mating to. They'll be supported on the bottom by the flat surface here, the top here on each of the kinds of rollers, and the top of this carriage plate will be just underneath the underside of the mounting plate for the extruder. So those are my constraints. Let's start with a simple part that will mate up with all of those features. So we're going to create, this is for the first time, we're going to create a new part within the assembly. All of this preparation about to come to fruition. So up on Insert Components, you click on the down arrow and you say New Part. And the surface that I'm going to use as the reference surface is the underside of the extruder carriage, extruder mounting plate. Now notice when I'm beginning to create things, it reverts over to the wireframe view. It's something you have to get used to, and sometimes it helps a little bit to rotate or move the view a little bit to refresh your mind in terms of what's where. We're now drawing a sketch, so that you know, we're drawing a sketch on the underside here of that bracket, and we're going to draw it out large enough to encompass the four wheels. Down here in the feature tree, you'll see that there's a new part, that this is the part that we're creating. It's in blue. That's your clue that this is the thing we're currently editing. So, and we're in a sketch. It starts out in a sketch. Let's just draw a rectangle. So we're going to draw, we're not going to get too particular about it, but we'll make it big enough, and then we can confine it as we need to. So corner rectangle, we'll start somewhere. In fact, I know right away that I want it to be in alignment. I'm going to rotate my view a little bit. I want it to be in alignment with this edge of the bracket. See that line right there? I want it to be in alignment, and if I pause briefly on that and then move out, notice it tries to help me. So I'm going to move out here, click and drag, and I'm going to drag in such a way that it encompasses everything that I need it to cover. Well, it looks like I didn't go exactly right, so that's okay. I'll drag my edges around a little bit, and in doing so it became unaligned. So let's do our first relation. We're going to add a relation right here. You see where it says relation? Add relation between that line, and let's make sure we get the right edge. I want it to be related to this right here, and I'm going to make them collinear. So that's my front edge. That's the first parametric relationship that we've created. Let's continue the process. I want this, I'm going to add another relation. In fact, this one will be a dimension. I want a dimension. You'll go to, under Sketch, Smart Dimension, and I'm going to dimension from, now pick one of these circles. Remember, we're going from this to the outer edge. So we can start with the edge to, let's get the right thing here, to that circle, edge to circle, and notice it's picking the center of the circle. That's the default behavior of Solidworks. So I'm going to make this a 1/2 inch, 0.5, just as per the specification. I'll accept that. I'll do some more dimensioning from here again to the center of this guy. I'll make that again 0.5. So now if you observe, my rectangle is starting to come into proper location and size. I'll accept that, and I can go ahead and repeat that same thing on the other side. There are relations that I can create that would help it be a little more automated, but I'm not going to do that right now. Let's do some more dimensioning from here to this circle here. It's already a 1/2 inch. Well, I wonder why. It's because those two wheels are already aligned because of their relation to the rail. So I didn't have to do that one, but I do have to do from here to here because that's not already predefined. So it's 0.75, make it 0.5, and now I'll accept that. I will exit the sketch. We'll come back into it in a minute, but I want you to see how we get this to be the right height for what we're needing to do. So all we've created is a sketch. In fact, if you open up in the feature tree The only thing present is that one sketch. Let's add a feature. Go over to Features, Extruded Boss Base. We're going to extrude this sketch. Well, how far do we want to extrude it? We want it to go down to the top of, remember what we pointed out earlier, the top of this guy right here. So we're going to go up to Surface, click on that surface, accept it. So now if I exit this part altogether, here I am with the beginning of a carriage. And if I move this thing, it moves. Now we're starting to really look like something. Let's start to blow some holes through this. That will make life much easier and make us able to actually mount these parts. Right now it's just a big old rectangle. So again, we'll go edit the part. We're going to edit right in context. We're going to do an extruded cut. Well, what are we going to cut? First of all, we want to cut for the 4 corner holes for the mounting the extruder bracket. So we're going to convert entities. And sometimes when you want to convert entities, I really want to convert that circle and this one over here, but it's not allowing me to select them. Instead, what you do is you go up to Display Style and tell it you want a wireframe. Having done that, now look, I can select that one, that one. Let's do them all. Let's do the 4 corners. I want those to go through, that one, this one here. Now what do I want to send through from down here? I just need a hole for the screw, so I'll click on that. Now this is in halves, so make sure you do both halves. Those two, same thing here, these two. Now the eccentric's a little bit different. I want to have the outer part of the eccentric boss is what the hole will be made for. So this guy and this one. Okay, they're converted. I'll accept that, and there they are. There's my 4 circles. Now I'm still in the sketch. I haven't told it what to do yet. I'm going to exit the sketch, but before I do so, let's go back to the standard display like this. Makes it a little easier to see what's going on. So I'll exit the sketch, and I'm in Cut Extrude. Remember, that's how we started all of this. We're in Cut Extrude. I want these holes to go all the way through. So I will say through all, accept it, and now I have holes in the places where I need them. Notice that the eccentrics are resting inside of them, and that I have a hole for the screw for the fixed wheels, the wheels with spacers. Not to mention I have the holes, I've started to make the holes for the screws that hold the extruder in place. So we're going to stop here, take a look at what we've created, and when we come back in just a moment, we'll be cutting out a little more detail that allows the hardware to function the way it is supposed to. Before I leave, let me do a file save, save all. Yes, I want to rebuild. And now I bumped into not an error so much, but it's a thing that you may forget to do. I certainly did forget to do it myself. It wants to know, what do you want to do with that new thing that you created? Do you want to save it inside the assembly or externally? You know what? I want to save it externally, but I want to do it my way. So I'm going to cancel out of this. Nothing's been saved yet. Let's go back to the feature tree and let's find that part. This is it right here. Right now it's named Part 1 in Context. Well, not the handiest name. Let's do a save part in external file. Now the way you get there, you right click, save part in external file. I'm going to click here and give it a name. I'm going to call it carriage 2 so it won't conflict with the one I created earlier. And I'll say OK. And now it knows that that's, even though it has references into this assembly, it's to be saved as a standalone part. As a matter of fact, I can right click and open it, and I can open it all by itself and look at it. So if there are things I want to do that aren't necessarily in context, there it is, ready to be worked upon. So I'm going to close this. I'll go back to my assembly. Remember, I hadn't finished saving it yet. I'll do a File, Save. In fact, let's do a File, Save All to make sure I don't have anything left out. Okay, and when that finishes, we know that all of the work, again, that we've done to this point is preserved. It moves nicely. The carriage is looking partly developed, and we'll be back in just a moment. Now that we have the holes, the through holes for the various hardware, let's create the recesses for the screw heads on the top and the recesses for the captive nuts on the bottom. Let's do the screw head recesses first. Let's see what size they want to be. Go over to the provided document. Now the holes for the fixed wheels are to be 0.38 inches in diameter. The recesses for the eccentric wheels to be 0.44. So 0.38 and 0.44. We'll come back to here in a moment to get the depth. So we've already we're going to go into editing the part. We'll create an extruded cut on the top surface. Draw a circle. Notice it helps me find the center. We drag out, dimension it, 0.38. Do the same thing over here. Again, a circle. .38. Now in the next one I'm going to do a little bit differently. I'll show you. First of all, we want the 0.44 centered on the current hole. That way the screw head will have room for its transit throughout the eccentric travel. So again, a circle centered there. Got to make sure we get the right center. We don't want the center of the guy down below. We want the center of the upper hole, the through hole, and this will be dimensioned at 0.44. 0.44. We'll accept that dimension. This other circle we're going to do a little bit differently. Same kind of drawing technique. Again, we'll find the correct center, draw it out, but instead of typing in a dimension, we're going to, when we're doing the dimension entry, instead of typing in a number, we'll go over to the dimension for its partner, double click on that, and accept it. And that way it becomes parametric. So in this case, if I want to change the diameter of both, I would change the source, the one over here. Here you can see it is a copy. And in fact, when I'm done, that will be the same diameter. Okay, let's exit out of the sketch. We're ready to do some extrude cut. We'll go back to that dimensioning again. Let's see what the dimension ought to be. We want to go, as you see over here, 0.14 inches from the far side. So we're going to extrude cut and offset from a surface. And the surface in question is the underside. And we're going to punch in 0.14. It happens to already be there. Okay, and we'll let it do it. So now I have the recesses in place for the screw heads. I've finished the top surface. Let's do a save, and then we'll come back and do the underside for the recesses for the nuts. Now the holes for the bracket are already placed, so we don't need to worry about them being out of position. In order to make things a little bit easier, now it's kind of hard to get to the holes that we want to from below. Two of them are visible, but two are hidden up underneath that rail. You can't even really see them here. Let's open up the carriage part, this new carriage part, separately. So I'll right click and I'll open it as a separate part. And you can see, well, there's my top. Look at the recesses. On the bottom for each of those four holes, I want to have yet another recess which is designed for the four hex nuts, the M4 nuts. Let's take a look at what those dimensions want to be before we go any further. Again, we'll go back to that same drawing, the carriage drawing. And if you look up here, it's a 7mm flat to flat, and the recess is 4mm deep. Now it's not offset from the surface anymore, it's just a plain old 4mm deep. So 7mm across flat, 4mm, and notice the orientation. The top and bottom flats are parallel with the top and bottom surfaces. That's to give the maximum room or beef right around here. If you had the pointed part here, it'd be getting kind of thin. So alright, so 7 and 4. So we'll go back to the carriage part and we're going to create those recesses now. So here we go. Feature, extruded cut, this surface. And we're going to create 4 hexagonal shapes using the polygon. So the polygon, we'll center it on here. Orientation, I don't care right now. We'll do all 4. 1, 2, 3, and 4. Let's dimension them across the flats. 7. Now we're in inch mode, so you'll have to punch in mm. So 7 mm. Same thing here and here. 7 mm. Using the method we had before, let's use a parametric method now, here to here. Instead of punching in a number, we'll say equals this and accept it. And we'll do that again. This to this and equals, and always go back to the same one. And there, now I have 4 7mm six-sided polygons, 7mm flat to flat. But I have not oriented them yet. Let's do that now. We're going to add a relation. Let's say make that flat, horizontal. We'll accept that. Do that again. Horizontal. This one, horizontal. All 4 the same. Now we could make them parallel to each other. There's so many ways to do everything. We'll accept that relation, adding. Now we're ready to do some extrude cut. Now remember, from the drawing we're going to go down 4 millimeters. So up 4 mm. That's the depth of each of them. And there are the holes now for the nuts, the captive nuts, to be inserted. So if we go back to our the top level assembly, you can see that in fact there are now holes for the nuts. That's kind of the end of the design, but what I'd like to do, I want to make sure that you all get in the habit of adding your hardware. There's nothing like adding a screw to a hole and finding out that the hole is too close to an edge, and even though it's in the right place, the head bumps into something. So let's, in the next step, we're going to add in all of our hardware, and there is some nice automation that we can use to do that as quickly as possible. So we'll go ahead and file, save all. This might also be an apt moment to change the color of the carriage that you've created. So once it's finished saving, I'm going to go back into this part and we'll go in, open the part. Let's change the base color. I'll make it something different than my earlier one so it can be easily distinguished. And I'll right click on it, go to the appearances dialog, a little icon, click on that, click on the body, and we're going to change it to, let's change it to a green. There's a nice lime green. Okay. So now when we go back to our assembly, it should be green, and that distinguishes it from the one I was working on earlier. You can make yours any color you want. So we'll again do a file, save all, and we're ready now to incorporate all of the hardware. Well, it looks like we're finally ready to add the hardware to this assembly. Thankfully, SolidWorks has some automation you can use. It's not perfect, but you do, after some practice, you can get used to using it, and it can be a good time saver. Right now, as you see, I have the assembly open in front of me. I also have the various bits of hardware on the left. There's a reason for that. I'm going to be dragging from one to the other. Let's start with the M4 screws. Let me see if I can find them here in the pile. There they are. I want to try to drag this M4 screw into the holes in the extruder bracket. And the way you start that is you find a circular feature at the base, like here in the screw, and you click on that and you drag it over, and you find a spot where SolidWorks guesses correctly where it belongs, and I release, and there it is. Boy, did that save a lot of work. I'll do it again for the next one. Okay. Let it settle for a moment, then I'll rotate around and I'll do it in the other two corners. 1 and 2. Okay. So those screws are in. We'll do the nuts in a moment. Now let's insert the M5 screws that are for the rollers, for the wheels. So here we go. Let's again, you'll find an edge, for example, right here. You got to move very carefully and click on it, and now drag it into position. And if you, oh boy, sometimes it fights you a little bit. You know, you just doesn't seem to be working. That's okay. Give up for a moment. Go back. Select, try a different edge. There, that worked. Make sure it's at the right height. It's not perfect, but once you get it going, like I said, it's a big time saver. Let's go back and do the same thing over here. Okay. Now I have a feeling this one's in the wrong place. See, it's centered on the hole and it should be eccentric. So we'll go back, we'll redo that one. It's easy for SolidWorks to guess wrong. This one, it can't guess wrong because it's not eccentric. Let's go back and fix this one. You notice that it's centered and it really shouldn't be. So I'm going to right click on that and delete it and get rid of it, and we'll do it over again, and hopefully this time it'll be more successful. Grab the screw, get into position. That one doesn't want to do it again. Something about that other side. So we'll grab this, and let's see if we can find the eccentric. There it is. That's the right location. Notice it's eccentrically oriented to the side, so as I turn the eccentric, that will move around in its travel. So that's good. The two eccentric screws are in. So now what I need to do is add the nuts on the other side. I'll minimize this. Let's get rid of them. We're done with the screws, and let's go over to the nuts. Let's find the M5 nut. Nylon insert hex nut. There it is. that up, not there. Let's go back. This guy. I'm going to size that up a little bit. This is what goes on the underside of each of these 4 rollers, and they have a nylon locking feature in them. I want to grab, just like with the screws, you want to grab an edge, and I'm going to put it to an edge over here. So I'll grab this edge there, drag it in, and once it's in place, drop it, let go, unclick. Do it again over here. Same thing, I'll grab this, let Solidworks find it. Okay, I got 2 of them. One more time. There. You got to move around a little bit and find the right location. Got one more of these to do. Okay, so now I have my 4 wheel nuts on. Let's do a file save because I don't want to lose my work there. And last but not least, we will insert the nuts for the extruder bracket. That's these M4 nuts right there. These are a little fussier because the automated feature does not know anything about flats. So they're going to come in some orientation, and then we're going to have to turn them to align them to the flats in the recesses. Can't see the other 2. That's easy to remedy because I'll right click on the rail and I will hide it for just a moment. Now it's still there, but it's hidden. So let's go back and do the same thing again. We'll zoom in on one of these. Going to have to get the nut settled into the hole. We'll find an edge, drag it in. Okay, that looks about right. Now notice, like I said, it's not oriented right, but at least it's at the right depth. Go do the same thing for the other 3. May not have grabbed it quite right. Moving around a little bit there. Did that get it? Let's see. Nope, it's too high. So I'm going to delete that and do it again. This is kind of par for the course. Let's grab that nice big edge right there and find the spot. There it is. Now it's in the hole, but not oriented, and we'll do that in a moment. Same thing again. Notice it gives me options, and only one of them is correct. That's the right one right there. When you're at the right spot, release. Can take a moment to find it. There we go. All right, good. So now all of those nuts are in and they're all in the wrong orientation. We'll fix that. Just like any other mating, you look at the area and you find surfaces that need to be related to each other. So I'm going to click away from everything. I'll do a mate of that surface with that. Great. Do that 3 more times. This with that. Right click. 2 more. That with that. Right click. Okay. This. Oh, I did bad. Let's clear it. I want that with that. Okay. So now the nuts are embedded. They're oriented correctly. Looks like all my hardware is in place. This is an assembly ready to go. The only thing I need to do now is to bring back my V-slot rail. Notice it's shown as hidden. I'll right click on it, show the component, and now it's ready for delivery. What we're asking of each student is to do a PDF printout of a view similar to what I'm showing right here, and that's what we want you to submit. So Let's get yourself oriented about like this, and let's first of all do a file save, and then we'll do a file save as, and the file type is, if you scroll down a little bit, let's find it, Adobe Portable Document Format, right there. I do want to view it after saving. So I save it, and there it is. That's a PDF ready for submittal. That's the conclusion of this lab. I hope you enjoy it, and feel free, as I said, to ask any questions if you have difficulty. Thank you for watching. This presentation is part of a series by Neil Rosenberg. Additional videos may be found on my channel at youtube.com.